You are hungry, not the kind of hungry that makes you check the kitchen. The kind that makes your body feel lighter. Your hands shake. Your stomach hurts. The hunters returned with nothing. The river gave no fish. The fruit trees are empty. Then someone rolls over a rotten log. Under the bark, pale larvae twist in the dark. Nearby, grasshoppers jump through the dry grass. A termite mound rises beside the camp. Would you eat them? To many people today, eating insects feels disgusting, desperate, primitive. But for ancient humans, insects may not have been emergency food at all. They may have been ordinary food, seasonal food, reliable food, and sometimes very good food. So did ancient humans really eat bugs? Almost certainly, yes. But the real story is not about starving people forcing themselves to swallow something awful. It is about how human survival depends on seeing food where others see nothing. Insects are everywhere. They live in soil, wood, grass, water. Nests, tree bark, animal dung, flowering plants. Some appear only for a few weeks, others can be found again and again in the same place. A large animal must be tracked, cornered, killed. But a termite mound does not run away, a cluster of larvae does not fight back. A grasshopper swarm can be collected quickly. For a small human group, that difference mattered. Big game can provide a huge reward. But hunting is uncertain. It costs time, energy, tools, coordination, and sometimes blood. A failed hunt leaves everyone tired and still hungry. Collecting insects can be less dramatic, but more dependable. This is the first important twist. Food value is not only about how large an animal looks. It is also about how much energy you spend getting it. A handful of insects may seem small, but if they are easy to collect, they can be worth the effort. Modern nutritional research shows that many edible insects contain useful amounts of protein and fat. Some also contain iron, zinc, and other nutrients. The exact value depends on the species, life stage, and environment. A beetle larva is not the same as a grasshopper. A termite is not the same as an ant, but the basic point is simple. Insects can be real food, not pretend food. Not just a survival trick, real food. The challenge is that insects leave less archaeological evidence than bones. Large animal bones survive. They carry cut marks, burn marks, breakage from marrow extraction, but a cooked grasshopper may disappear almost completely. A soft larva leaves little behind. An ant nest gathered thousands of years ago may leave no obvious trace. So ancient diets can look more meat-heavy in the archaeological record than they really were. This does not prove every ancient group ate insects. Human diets were different in different places. But it reminds us that missing evidence is not always evidence of missing behavior. Ethnographic studies of recent and modern hunter-gatherer and small-scale societies show that insect eating has been common in many regions. People collect termites, caterpillars, grubs, grasshoppers, ants, larvae, and other species. The methods are often highly skilled. They know the right season, the right tree, the right soil, the right weather, the right stage of growth. This is not random grabbing, it is knowledge. Imagine following an elder through dry woodland. They stop beside a tree you would ignore. They touch the bark, listen. Then cut into the wood and reveal fat larvae hidden inside. To you, the tree looked dead. To them, it was a food store. Or imagine a child noticing insects moving toward one patch of ground after rain. The adults dig carefully. Inside is a nest full of eggs or larvae. The child did not just find bugs, the child found calories. This matters because gathering insects may have allowed more members of the group to contribute food. Children could help, older adults could help. People recovering from injury could help. You did not always need the strength to throw a spear or chase an animal. You needed patience, memory, good eyes, and knowledge of the land. Some insects could be eaten raw. Others were safer or more pleasant after cooking. They could be roasted on hot stones, dropped near coals, wrapped in leaves, mixed with other foods, crushed into paste, dried for later. Cooking could change texture and taste. It could also reduce some risks. But ancient people still had to be careful. Not every insect is edible. Some insects contain toxins. Some spray irritating chemicals, some collect dangerous substances from plants. Bright warning colors can signal danger, bad smell can signal danger, hairy bodies, stingers, or unusual behavior can signal danger. And sometimes the signal is not obvious. So how did ancient humans know what was safe? The same way humans learned many survival rules: observation, experiment, memory, teaching, and sometimes painful mistakes. Someone eats a certain larva and becomes sick, the group remembers. Someone discovers that roasting removes a bitter taste. The group remembers. A child reaches for a brightly colored insect. An adult stops them. Knowledge becomes protection. Over generations, food rules become tradition. This is the second major twist. Ancient humans were not simply more tolerant to disgusting food. They had a different map of what counted as food. Disgust is partly biological. Rotting smells, feces, and signs of disease can trigger avoidance. That protects us, but disgust is also shaped by culture. One society sees shrimp as normal and insects as revolting. Another sees grasshoppers as a snack. Another values ant eggs. Another avoids all of them. The insect did not change. The food category changed. For ancient humans, the question may not have been, how could anyone eat that? The question may have been, why would you ignore it? Season also matter. During one part of the year, insects may have been rare. Then rain arrives, plants grow, termites emerge. Grasshoppers multiply, caterpillars appear on specific trees. Suddenly, the landscape produces food in a burst. A group that understood these cycles could collect large amounts quickly. That knowledge could be especially important when hunting was poor or plant foods were limited. Insects could fill a gap, not because they were always the final choice, because they were available at the right time. The best survival foods are often not the most impressive. They are the foods you can count on. There is also another advantage. Insects are small enough to combine with other foods. A few larvae may add fat to a meal. Termites may be eaten with roots or seeds. Grasshoppers may be roasted and shared. Bee larvae may come with honey. A food does not need to be the entire meal to matter, it only needs to improve the meal. And in a world where every calorie had to be found, small improvements could matter. Of course, insects also carried risks: parasites, bacteria, toxins, allergic reactions, stings, bites, and contamination from where they lived. An insect collected from clean wood was not the same as one living in dung or decay. Ancient humans did not know microbes by name, but they could observe patterns. Some foods caused sickness. Some methods reduced it. Some seasons were safer. Some species were never touched. The knowledge may not have been perfect, but survival never requires perfect knowledge. It requires knowledge that is good enough, often enough. Now imagine the scene again. The hunters have failed. There is no meat. The group is tired. You turn over a log and see larvae. Your modern instinct says no. Your ancient teacher says yes. Not all of them. Not from every tree. Not without checking. But these ones, these are safe. These are rich. These are food. You roast them near the fire. The smell changes. The texture changes. A child watches carefully. Tomorrow, that child may remember where to look. This is how survival knowledge moves through time, not through books. Through hands, eyes, taste, warning, and repetition. So did ancient humans really eat bugs? Yes. Probably in many places, and in many different ways. Not every group, not every species, not every day. But enough that we should stop treating insect eating as a strange failure of civilization. For many humans, across many environments, insects were part of the landscape's food system. They were protein hidden under bark. Fat inside a larva. A seasonal harvest in a termite swarm. A meal collected by children, a backup when hunting failed. And sometimes, simply something people enjoy. The uncomfortable truth is that ancient humans may have been better at seeing edible possibilities than we are. We walk past food because our culture tells us it is not food. They could not afford to be so narrow. The log in front of you is not empty. The ground is not empty. The air is not empty. The question is whether you know what you are looking at. If you enjoyed this journey into the distant past, subscribe for more stories about ancient humans and human evolution.